Hi friends, welcome back to our channel. Today we are going to discuss about PT slabs, that is post-tension slabs. The use of PT system started from 1950s. The intention is to simplify the task of designers and contractors to produce effective and economic structure. PT slab is not complex. The design, structural behavior and techniques are simple and very similar to RCC structure. PT slab has cable tendons passing through it. Those are placed under tension. This tension will make PT slab more stronger with minimum reinforcement. The main advantages and application of post-tensioning system. PT slab reduces shrinkage cracks, therefore no joints are needed. If any cracks are formed, that will be held tightly together. In PT, we will get thinner slabs and other structural members. We can even use PT to replace pile cap and mat foundation. In most cases, PT slab will be without beams, so formwork erection will be faster. PT provides longer span columns, so we will get more space in the building. PT slab are thinner, that reduces the floor-to-floor height, and additional floor can be added to the same height of building. Main disadvantages of this system. Skilled and experienced workers are required. Poor workmanship may lead to accidents. Since there are a number of tendons and wires are spread inside the post-tension slab, it can result in corrosion. All shaft and cutouts shall be considered during the initial stage of design. Additional coring or cutout may lead to cutting of tendons. People have been dismembered and killed when the cable are cut and burst out of the concrete. So these are the main advantages and disadvantages of PT system. Different type of PT slab are solid flat slab with drop panel, beam and slab, banded flat slab, coffered flat slab with a solid panel, banded coffered flat slab, and ribbed slabs. Next we will discuss about the components or the basic part of PT slab. This is trumpet, anchor block, duct, GI duct, strands, grouting pipe, chair, wedges, polystyrene board. The basic part of PT system is tendons. Tendons have one or more pieces of steel cables coated with a protective coating and placing through a duct. Then this duct will be connected to an anchorage. There is two types of tendons, bonded tendons and unbonded tendons. Unbonded tendons are protected by a layer of grease inside a plastic duct. This will be made and supplied by the manufacturers. Here we are using bonded tendons. Bonded tendons are protected by using GI ducts of oval or circular in shape. There are different arrangements of tendons that are fully banded tendons, uniformly distributed tendons. Here we are using uniformly distributed tendons. The last one is 50% banded and 50% evenly distributed tendons. To know about more, you can refer into Concrete Society Report 43. The next part is strands. Strands are twisted steel cable composed of 2, 3, 7 or 19 high strength steel wires. Here we are using 7 wired strand of 12.7 mm dia. Strands are in a coil form. Based on the required length, we will cut them inside and install through a duct. After installation, one end will convert into an live end, other will be dead end, or both will be live end based on the design. The dead end will made in the form of an onion by using an hydraulic pump and jack to get proper bonding. Next one is GI duct. GI duct is very thin. The standard length of GI duct is 5 to 6 meter respectively. Plastic ducts also available in market. Here we are using GI ducts. GI ducts have wave-like profile. Based on the design, we will get the profiling height. We will arrange the duct in X and Y direction based on the design. Next one is chairs. Chairs are used to give support for ducts while doing profiling. There are different sizes of chairs are available. Chairs are very light in weight and easy to handle and transport. Chairs are epoxy coated steel rod. Next one is anti-bursting reinforcement. This is the anti-bursting reinforcement. There are three types of anti-bursting reinforcement. Rectangular helix. This is rectangular helix, and we have circular helix and U-bars. These will be placed in the anchorage zone to reduce cracking due to tensile force. The next part is anchorage. Anchorage are used to anchor the tandem into concrete while terminating. The main function of anchorage is to transfer the stressing force into concrete once the stressing process is complete. There are three types of anchorages: dead end anchorage, live end anchorage and pan end anchorage. First one is dead end anchorage. This is a dead end anchorage. A dead end anchorage is consist of anti-bursting reinforcement, grouting pipe, strands and chairs. The anti-bursting reinforcement will place it in the end of duct. From there up to 1 meter, strand will be exposed and the end is converted in the form of an onion by using hydraulic pump and jack to get proper bonding, and this will be supported by using chairs. This is called live end anchorage. Live end anchorage is placed in the jacking end. Live end anchorage consists of anti-bursting reinforcement, duct, trumpet, grouting pipe, polystyrene board and strands. This polystyrene board is placed instead of anchor block. Actually, anchor block is a steel block that will be pocketed inside the concrete to avoid rusting. Once the concrete is done, before stressing, we will remove this polystyrene board and place the anchor block and pocketed or patched by using cement sand mortar once the stressing process is complete.
Okay.
Now the last one is pan end anchorage. This is a pan end anchorage. A pan end anchorage consists of anti-bursting reinforcement, duct, trumpet, grouting pipe, polystyrene board and pan box. This will be used where we don't have enough space to do stressing. Next we will discuss about the working principle of post-tension slabs. Post-tensioning is a technique for reinforcing concrete. Steel tendons are placed in the forms before the concrete is placed. Before applying any service load, we will stress the tendons tightly and anchored against the outer edge of concrete. When a huge live load is brought into a structure, its concrete slab undergoes tension, which causes the formation of cracks. Ultimately, deformation occurs. To prevent or to reduce this, we will use post-tension slabs. When the tendons are pulling, concrete is squeezed. In another term, concrete is compacted, which increases the compressive strength of concrete. At the same time, when the stressing is done, tensile force or tensile strength is increased. Overall, the total strength of concrete is increased. So this is the working principle of post-tension slabs. Next we will discuss about the PT drawing. Now we will discuss about PT drawings. All these PT drawings are given by PT contractors. They will make the drawings based on design. Basically, we have 5 different drawings that are framing and loading plan, post tension layout X direction, post tension layout Y direction, post tension top and bottom reinforcement X direction, post tension top and bottom reinforcement Y direction. Along with this, we have 2 general notes and design report also. Now we will go through each drawings. First we will go to general notes. From this we will get all informations about the concrete strength and the aggregate size, that and all we need to use for this slab. And here we have the reinforcement details. Covers need to be used, and the sizes and properties of all the PT parts all are mentioned in this note. And here we can see the stressing force need to be applied and the stressing sequence. Like that, all basic informations of this PT slab is given in this general note. Like that, we have one more note. In that, all the sectional details of each parts of PT slab is given. All the properties of each material and spacing all are clearly mentioned in these drawings. Here we have the anchorage detailing, both dead end and live end anchorage detail, all the parts details, beam details, pan box or pan and anchorage detail, bar chair detail, tandem with beam reinforcement detail, reinforcement at column place, column location, punching shear details, shear link details. Like that, all required informations and detailing are given in these notes. Next we will go to framing and loading plan. From this drawing, we will get the thickness of slab. In this slab, we can see different thickness in different parts, portions or different locations of this same slab. Here we have 200 mm, here 220 mm. Like that, in same slab we have different thicknesses. And here we can see the locations of beams. In few locations we have beams, those are marked in this framing plan. Like that, we have a pre-camber and we have one drop panel also. Not one, we have few drop panel also in this slab. Drop panel is due to the changes in column orientation, and to reduce reflection we are using this pre-camber. So this pre-camber location and drop panel location also we can find from this framing plan. Like that, here also we have a general note. In that we can get the typical detail of beam, the how to consider the reinforcement length and how to calculate them. All the basic information we will get from this typical detail. Like that, we have a beam schedule over here. In this, all the sizes of beams is provided. Like that, we have sectional details of pre-camber. Next we will go to post tension tandem layout X direction. In this drawing also we have a general note. All the legends used in this drawing is mentioned in this general note. From here we can identify all the legends and what they are indicating. Here we have different number of strands inside one tandem. So those different type of tandems are mentioned by using different legends. Those are also given here. The tandem force and characteristics of concrete is also mentioned here. In this slab we are using M45 grade concrete and the jacking force is 80% of the breaking load of strands. From this plan we will get the tandem direction, X direction tandems, and number of strands used in each tandems. Like that, the profile height, all the profile heights are mentioned in this drawing. So based on this drawing we will do the profiling. Location of dead end anchorage, live end anchorage and pan end anchorage we can find from this drawing. Like that, all cutouts and shafts are considered in this framing plan. The drop panel are using to increase the shear strength of slab. Here we are using drop panel because of the column reorientation. Like this, we have Y direction tandem layout also. In this drawing we will get all Y direction tandems and its profile heights and the live end, dead end and pan end anchorage location. Like this, all informations we will get from this Y direction tandem layout. Next we will go to post tension
top and bottom reinforcement X direction. In this layout or in this drawing, we have a general note. From this general note, we will get all the legends used in this drawing. Like that, the cover used for both bottom and top reinforcement is also given. The reinforcement notations is clearly mentioned here. It will be easy to read by using these informations. The characteristic strength of concrete and the tandem details and all the steel details and all required details are provided over here. Next we will go to the layout. From this layout we will get all the reinforcement details in the X direction. Like that, we have the basic reinforcement details also. From this drawing, we will get all the reinforcement need to use in this slab. Like that, they provided the punching reinforcement detail of each column in detail. From this detail, we will get the spacing between each layers of this punching reinforcement. Like that, the number and the diameter of hooks is provided. By using these details, we can install them inside very easily. We have the sectional detail of this punching reinforcement over here. So by using these details, it is very easy to install them inside. Like that, we have the detail of shearling also. Now we have a sectional detail of drop panel over here. The reinforcement detail around tower crane area is given. Reinforcement detail around shafts and cutouts is also provided. The reinforcement detail in the lower and high profile of tandem is also provided. So like this, we have Y direction top and bottom reinforcement detail also. In this drawing, we will get all the reinforcement detail in the Y direction. By using these drawings, we can do the reinforcement in sight, or by using this drawing, we will do the reinforcement in sight. So this is all about drawing. Now we will go to site and check how to install this or how we installed them in site.
Next we will discuss about method of casting or the installation of PT works. In our last video we discussed about the formwork used here for slab support. Once the formwork is done, on top of plywood we will mark the tandems, live ends, dead ends and tandem routings by using spray paint. Once the tandem marking is done, we will place the bottom reinforcement. Here we are using weld mesh for bottom reinforcement. In weld mesh we have B1 and B2 bars. B1 is bottom bar and B2 is top bar. Here we are using a 25 mm cover. Once the bottom mesh installation is done, we will place the live end anchorage and we will make a hole in this top end to pass the strands. After that, we will tie the anchorage with
stop end by using a binding wire.
After that, we will do the duct arrangements based on the drawing. Then this duct will be connected to the anchorage, and the joints and the connections are sealed by using duct tape. Once the duct installation is done, we will do strand pulling. We will pull the strand from dead end to live end. After that, we will cut them and make the dead end anchorage. After pulling of strands, we will do tandem profiling with the help of chairs. Chairs will be placed under the duct and tie them with the duct by using binding wires. The higher and lower profiles will be given in PT drawing. Based on that, we will mark the higher and lower profile on top of duct. After that, we will do the profiling. Once the tandem profiling is done, we will place the grouting pipe on top of the trumpet in the live end, and we will place the grouting pipe in dead end also. In some cases, in the long tendons, we will place the grouting pipe in the intermediate of tendon. Once the PT work is done, we will do the top reinforcement and all MEP works. One more important thing is we have to consider all the sleeves and cutouts before casting itself, because once casting is done, the cutting and cording are not recommended. Once the PT work are done, we will do the top reinforcement. Here we can see how we will do the top reinforcement in site. In drawing, from the drawing we will get all the informations about top reinforcement and bottom reinforcement. So based on the drawing only we are doing all the reinforcement works. So this is how the top reinforcement in the edge of slab. All around the column we can see punching reinforcement also. This is how we will do the punching reinforcement. In manhoist and tower crane cutout areas, we provided hidden beams along with additional reinforcement. Later, concrete will be poured to cover these cutouts. For all shafts and cutouts, additional reinforcement is required. Here we can see how to give the reinforcement in the shaft cutout area. Here you can see the drop panel area, where the thickness of slab will be more than other areas and reinforcement arrangements will be same as other areas. In some areas, we have slab thickening. That means the thickness of slab will be more in these areas. If the deflection is more, we will do slab thickening.
reinforcement works?
We will clean the full site by using air compressor to remove all the binding wires and all the waste material from the slab. After that we will do concreting or we will do the slab casting. The important process of PT slab is stressing of strands. Before doing stressing, we will remove the polystyrene board. Then we will insert the anchor block. After that, we will fix the wedges. After the wedges are installed, marking is done on each strands at the edges of anchor block. Hydraulic pump and jack are using to do stressing. The amount of stressing will be 80% of braking load, that is jacking load. To identify the amount of stressing, the pump will be equipped with a pressure gauge. After stressing, the elongated length of each strands are noted and tabled to find if the elongation is within the limits. Once the concrete achieves the required strength specified in the design report, we will start stressing. the stressing is completed, stressing report will be verified, and if found okay, then strands are cut very near to the anchor block, and the pocket are patched by using cement sand mortar. Once the stressing is done, the last process is grouting. The last and final process of a PT slab is grouting. Grouting of tendon or duct is an important operation in PT slab. The main equipments and materials for grouting is this is a mixer. In this we will prepare the grout for grouting. We need water to make grout. Here we are using ice to maintain the temperature. The minimum temperature of grout is 10 degrees Celsius and the maximum is 25 degrees Celsius. We need a pump with all necessary connection hoses, valves and measuring devices for this grouting operation. The main materials used to make grout is cement and cable grout admixture is needed. We are using Sika Intraplast CFG. This will help to improve the flow of grout without segregation, and this is suitable for hot climatic conditions. Before starting grouting operation, there is few tests for grout. Here we are doing fluidity test, bleeding test, compression strength test, and we need to check the temperature of each material before starting the grout preparation. This is the hose pipe we are using here to transfer the grout into grouting pipe. The pump will maintain a pressure of at least 1 megapascal and it should be equipped with a pressure gauge. So this is the pressure gauge. This will connect it to the hose. The main functions of grouting is filling of duct fully with grout to protect the tendons against corrosion and to provide the bond between the strands and the duct. Grouting is a continuous operation of injecting grout into the duct. The mixing ratio of grout we can find from product data sheet of Sika Intraplast CFG. Based on this ratio, we will mix the grout inside or we will prepare the grout inside. Once the grout preparation is done, we will cover the grout mixer tightly to prevent evaporation. In grouting operation, the temperature plays a very important role. Once the grout is prepared, before starting grouting operation, we need to check the temperature and make sure that the temperature is in limit. After that, we will do the fluidity check. Here we are using cone method for fluidity test. Qualified and experienced technicians will do this grout test. After this test, we will get to know the flow of this grout. If additional water is required, means we can add after this test, or from this test we will get to know if any addition of water or material or something is needed, means we will get to know after this test. Next we are doing bleeding test. The test consists of measuring the quantity of water remaining on the surface of the grout which have been allowed to stand protect from evaporation. Next one is Prism test. It's a compression strength test. By using these grout cubes, we will identify the compression strength of grout. So these are the three grout tests we are doing here. There are a lot of grout tests, but here we are doing these three tests. After grout test, the next process is injecting grout into grouting pipe. With the help of a hose, we will transfer the grout from grout mixture to grouting pipe. A trial grouting is required to make sure that the grouting is done or the equipments are working properly. Here we are doing that with the help of water. Trained and experienced person is required during the grouting process. The grouting will start from the lowest pipe to highest inlet. It will continue up to the overflow of grout. Maximum grouting length in one operation is not more than 50 meter. Like that, after grouting, the overloss of grout need to be prevented. The outlet need to cover for more fast grouting, and the cover need to remove to allow the water bleeding after grouting. After setting off grout, we will cut the grouting pipe and patch them. One of the great advantages of PT slab is you can remove the slab formwork after stressing, which will be usually within a week of time. After formwork are removed, we have to prop the slab at least 50%. Here you can see the 50% propped slab. Inside, we can identify the PT slab by looking at the slabs of it. You can see the tandem marking. If the marking are not visible, tandem marking should be done again. It will be an indicative for fixing of services.